Hello, everyone. My name is Deirdre Denman, and I'm the Marketing Coordinator at EandM. Thank you for attending our webinar titled Automated Quality Control, Keeping an Eye on Your Production. After the webinar, we will be doing a short Q&A. Please type any questions or comments into the Q&A box, the chat box, or you can email us at webinars@eandm.com. I'd like to introduce your presenters for today, Akshay Bhatti, SICK Product Specialist, and Tony Laughlin, Northern California Sales Manager at EandM. I'll first turn it over to Akshay to get us started. Good afternoon, Akshay.
Good afternoon. Thank you, Deirdre. Good afternoon, everyone. My name is Akshay Bhatti. I work as a product specialist for SICK Sensors here at EandM. And today I'll be doing a webinar on SICK Inspector. To start with, I'll start with the introduction where I'll introduce the camera, what exactly it is. Then I'll be going through the marketplace graph for machine vision. Then I'll be explaining why Inspector, what makes it unique. And then I'll be going into the live demos. So Inspector is a 2D vision sensor from SICK, which is divided into 3 categories: the I series for inspection, PI for position inspection, and PIM for position inspection and measurement. And in my live demo, I'll be explaining all the PIM tools. So this is the machine vision graph, and which is divided into 2 categories: vision sensor and vision cameras. So that's where Inspector comes into picture by bridging the gap between the two by providing features which are equivalent to a vision system, but fraction of the cost. So why Inspector? First of all, the programming software. As you can see over here, this is the engineering software from SICK called as SOPAS. To program this camera, you don't need any prior programming knowledge. You just have to use certain tool sets and you can configure the camera really quickly. Moreover, this software offers you an emulator, which is basically an offline testing tool where you use a reference image and use certain tool sets, create the recipe, and transfer it to the camera. The advantage of having this tool is that you don't have to have the camera connected live, so you reduce time and cost because you won't have to stop the line if the camera is in action. Speed. So this camera goes as high as 250 frames per second, where FPS means frames per second. And what exactly it means is that you take more the frames and you'll get a better picture quality. Like you can see in the example, 30 FPS is a blurred image, but if you double the frames in 1 second, then you get a better picture quality, as you can see in the image. Moreover, flexible optics and housing. So as you can see over here, we can exchange the lens based on our requirement, or we can use certain filters based on what the material of the target is, or we can use an accessory called dome. First of all, lens. So if you have an application where the camera is already being used, but now the field of view has changed, you need a wider field of view, or you need to inspect in detail. So in that case, you need a focal length which is higher. So in that case, you will be taking a 10mm lens. This is an example. So if we use a 6mm focal length lens, then you will get a wider field of view. But if we increase it, then we can inspect more parts in details. So we offer 4 different variants of lens. This is an additional accessory called dome, and it's used especially when the targets are reflective in surface or it's shiny. And what it does is that it distributes the light evenly on the target so that we get rid of the glare. This is just an example how the camera sees the object with dome and without dome. And I'll get into the details of this application in my live demo. Next is the color filter. So let's look at the first color wheel. These are the colors of the target. Let's take an example that our color is this shade in this red color. And if we apply a red filter on the camera, as you can see over here, there's no contrast. The reason is because there's no absorption of light. The red target comes as is. But if you use a blue filter, most of the light gets absorbed by a blue filter, and that's how it makes a contrast. So you get a little bit of contrast over here, and you get a better quality picture. Flexible communication. So first of all, it offers digital IOs. You can use an input to change recipes. You can use outputs to have a visual indication. Then it also offers field bus communication like Ethernet IP, Ethernet TCP IP, and EtherCAT. Moreover, when it comes to web server, you can access the camera using its IP address. You can change the recipe or check the status of the camera. And then lastly, it has something called FTP, which stands for File Transfer Protocol, where basically you can store the images externally somewhere by just defining the address of the location. Okay, now let's get into the live demo. So my first demo would be about doing inspections on a Listerine mouthwash bottle. So what we are doing over here is we are performing a quality check where there are three objectives of this application. First is to verify the logo. Second, we have to check the fill level of the bottle. And third, we have to check whether the label is present and at the right position. So in this one, we'll be using all the PIM tools as I'll be explaining in my demo. And I'll be using three targets in my demo. The first one would be a pass because it has certain fill level. There's a logo present, which is this one. And the placement of the label, this label. So I'll explain in details in my demo. And this is the second target, which is fail. And the reason is because fill level doesn't match. And third one is a fail because logo is not present and fill level does not match. And my second demo would be about using cans to see the presence of salt. Now let's move on to my first demo. Give me a second to start the camera. Okay, so my camera is connected. I just need to share it. Give me a second. Sorry, it's taking a little while. Camera is now connected and okay, so this is how it looks. So now I have the camera connected live to the software called SOPAS engineering tool. And as you can see, the bottle is not visible because image settings are not clear. So as a first step, what we'll do is we'll click on add. So what it does is it adjusts the exposure on its own. And now you can see it's adjusted, but sometimes we have to manually tune it. So in this case, as you can see, there's a lot of light. So what we'll do is we'll reduce the exposure a little bit. I'll just increase a little bit. Again, we have to find a spot where there's not glare and we can detect our objects which we are trying to detect. So yes, now it looks good because on the fill level, on the logo, and on the label, we don't see any glare and it looks good. As a next step, we'll click on Teach Reference Object. So now this is the reference image which is saved in the software for now, and we'll be using certain sets of tools to achieve our objectives. We have a variety of tools over here, as you can see over here in this column. But for this application, we'll be using certain sets of tools. First would be Object Locator. So we are using Object Locator, and why we are using it, the reason is we are looking for the presence of the bottle. As soon as we detect the bottle, then only we start the detailed inspection. This way, we don't have to do detailed inspection for every instance when the camera is triggered using a trigger sensor. So we can place Object Locator on, say, anywhere, but in my case, I'm just putting it on the cap because bottle would be of the same size and the cap will be present. That's how we can make sure bottle is there. Now, as you can see over here, it doesn't detect anything. The reason is there's not enough contrast difference. So what we'll do is we'll adjust it a little bit. So as I reduce it, it turns green, but still it does not see over here. So I'll reduce it further. I'm trying to find a point where it's completely green on the edges, and yes, this looks good. After this, I'll uncheck this box which says allow rotation. So what happens is in this case, the bottle will be at the same position each time, but sometimes it can happen that the objects are rotated and we still want to do detailed inspection. So in this one, I'll uncheck this, and then it says allow objects anywhere in the image. I would say no, because cap will always be in this position. So that way I'll reduce the inspection area to say something like this. Now it will only look for the cap over here. Once it finds the cap, it will start the inspection. So as a next tool, I'll be using something called pattern tool to detect this logo. So now it sees the pattern, it's saved in the camera in this tool. As a next tool, our next two objectives are fill level and this label, the position of the label. So for the fill level, I'll be using a tool called edge tool. As you can see right now, it's red. That means it's not uh, able to see edge really clearly, the fill level. So again, we have to find a spot where this edge turns green. That means there's enough contrast and it detects it. So again, we have to play with it, fine tune it. Now I'm trying to find a spot where it turns just green. Okay, at this point it turns green. That means the edge contrast is good. Just to make sure that it's good, it's stable, we'll go to the live image to see if it's green and stable. And yes, it is. So, oh no, but it just saw a red one. So maybe we can reduce it further down to just have an optimized image. Okay, now it looks good. So fill level is done. As a next step, we have to find the label. So again, I want to mention this thing for solving any applications. There are a variety of ways, but we have to find a way which uses less amount of tools so that it doesn't take a lot of processing time to do each inspection. And that really matters if you are using the camera in very high speed application. So going back to the application, I'll be using an edge tool over here to find the label. So say for instance over here, again it's red. We have to play with the contrast, turns green. Okay, it turns green just to verify it's stable and good. Yep, it remains green. There's a good contrast. And as a next tool, our next objective was place the the presence of label and the position of label. So how do we make sure that it's always at that position? And we can do that by using something called a distance tool. So if the fill level matches, that means the label should be this far away. So that's why I'm using a distance tool. If the distance doesn't match, that means either the fill level is not correct or the label is not at the right position. So now I have all my tools over here. Um, this is my live mode. So this is my first target where everything is passed. And also you can monitor these things over here. So this is a results tab where we can see the status of all the tools. And moreover, we have over here where we can set our digital inputs, outputs, like right now, all tools are passed. So we have it triggered on output number 3, like over here. So now let's change the target and use the defective one. So if I put another bottle over here, um, as you can see, the fill level doesn't match, so it says red. That's why it is failed. It's triggered on output 2. And now if I put my third target where the pattern, the logo is not present and level is not matching, so that's why it's a fail. As you can see over here, also in the outputs tab, it failed. Moreover, I would like to show you one more thing, statistics. So there's something called statistics where you can check what is the frame rate of the camera, how many images passed, how many failed. So to fetch statistics, we have to click the camera, click run to make it in to store the configuration in camera's memory. So I'll click run and save it to flash. Okay, now the configuration is saved. So I can click on fetch statistics, and as you can see, it tells me how many images it took. Like right now, we are not using trigger, it's on free trigger. So that's why these images, the number of images will change. For instance, if I click fetch statistics again, from 21, it moved to 207 because it's taking snapshots as fast as it can for the frame rate. So now over here, you can see we have kept our fail target for when we started this fetch statistics. That's why it's a 100% fail rate, 207 failed. So if you have like all the different targets running, then you can get all the statistics from this tab and figure out what's your read rate. Okay, so that was all about my demo 1. Now I'll be handing off to Tony, and in the meanwhile, I'll fire up my second camera.
Thank you, Akshay. Hello, everyone. My name is Tony Laughlin. I'm the regional sales manager here at EandM. I was just going to take this minute and say hello while Akshay does a changeover for his next demo. As a reminder, if you please be sure to type any questions you may have into the chat. We'll get to those after the second demo. Aside from Akshay, who supports Northern California, we have a couple very talented product specialists for SICK, one in Southern California and one in the Pacific Northwest. They're here to consult and support you on your projects. So if you want to have a conference call or a video call to review a project or the viability of a solution, please reach out because we're here to help support you. I'd like to remark that Akshay is using a software named SOPAS. SOPAS is a free engineering download on SICK's website. That address is sickusa.com. He's using SOPAS to identify and correct real-world issues that engineers face, like the way he was fixing those edge contrasts on the fill line. The tools offered in SOPAS assist him in making these fixes. And as you can see, he's making these engineering changes in minutes and not hours. Not to mention that he's doing it in front of everybody while presenting in a webinar, so no pressure there, Akshay. The point being is SICK has invested in a creative and intuitive engineering tool and have provided it no cost to the end user. SOPAS is also used to program a number of other products in SICK's portfolio, like their 1D and 2D barcode readers, their IO link sensors, and automation light grids, just to name a few of the products that you can configure with that software. The next demo that Akshay is going to present is an actual application that EandM solved using an inspector at a tomato canning facility. This plant sent cans down the line at 300 cans per minute, and they needed to ensure that a dose of salt was in the can before filling it with tomato. With the line moving that quickly, a fast frame rate was required. On this application, the inspector captured 33 frames per second. And other than the speed, our competition had failed with lighting. The other vendors had required an external light, and using that external light had created, using that external light on the shiny metal cans that he'll show you, it created a reflection and a glare, so it was damaging the image. When we tested it, and then what Akshay will show you next, is that using the inspector and dome light that you saw on an earlier slide, we provided a single complete lighting source, allowing for a clear field of view. So with that said, I'm going to pass it back to Akshay for his second demo. Thank you guys for attending our webinar. Appreciate it.
So can you see my live view of the camera?
Yes, Akshay.
Tony, okay, thank you. Sorry for the lag, guys. Sorry, I don't know why it didn't take IP address. So, but now it's working fine. Now I'm in the live mode of camera 2. So as a next step, I'll click on edit, and what it does is it's adjusting the exposure again to get a good view. But again, there's a lot of light, so we have to play with the gain over here, exposure, so that we get a clear image. And once again, we are using a stainless steel can. So with any camera, if there's an internal light or also external light, there'll be reflection for sure. But in this case, we are not seeing that because we are using a dome accessory. And now we are trying to get a perfect image. So again, we have to play with this a little bit. Okay, maybe. Okay, this looks good. So as a next step, I'll click on Teach Reference Object. It saves the image. And again, we have certain sets of tools over here. In this one, we are trying to detect the presence of salt, which can be anywhere over here. So what I'll be using is a tool called Pixel Counter. So I'll be using this tool, and then I'll be using this tool to cover the entire base so that if anywhere salt is there, it triggers an output. And okay, now we have covered the base. And as you can see, it's yellow right now. We have to play a little bit with the intensity range. So now I'm trying to get to a point where we cover all of this area. And as you can see, all these yellow points are the pixels which camera is seeing. And we have to come to a point where all of that is covered. So maybe I can reduce this a little bit. This one I should increase so that, yeah, something like this. Okay, so now we see the entire base of the can, and these are the number of pixels which we are seeing right now. So I should adjust the threshold value, and maybe I'll put it somewhere here. So what's happening over here is I'm using a tool called Pixel Counter. We are getting the pixel count of slightly above this number. As soon as I put salt, or if there is any salt in the can, the pixel count goes low, and that's how it triggers an output that, okay, there is salt. So let's go to our result tab again and go to the live mode. As you can see, right now it's red. So when I put salt, or if there's a little bit of salt, like I did it right now, it turns green. So that's how, as soon as salt is there, it sees that, okay, there's a salt and triggers an output. And now if I replace this can and put another empty can over here, it should again turn to red. That means no salt. And again, when the salt is there of the third can, so it will be like I put a little bit of salt and it turns green again. So that's how we are able to detect the presence of salt using this tool. And that was all about my demo. Now, if you have any questions, feel free to answer. Feel free to ask me. So I'll just switch to the presentation.
Thank you, Akshay. So yes, we would like to open it up for a couple of questions. Please type any questions you have into the chat or Q&A box, or you can email us at webinars@eandm.com. Akshay, we did receive a couple of questions. The first question that came in was, can this camera do a 3D inspection?
No, when it comes to 3D inspections, we have another camera called Tri-Spectre that will be used for a 3D inspection. With a 2D camera like this, you can use multiple cameras if you have to inspect the bottle from all the sides, but it's better if you can use just one 3D camera on top and get the entire view or inspect the entire bottom. So it depends on the application.
Okay, and then another one that came in, how many recipes can you have on this camera?
You can have up to 32 recipes, 32 reference images, and store it, and based on what's needed, you can just switch it. Are there any more questions?
No, it looks like we don't have any other questions. That can conclude our Q&A portion of the webinar. Thank you, Akshay, Tony, and everyone who attended today. If you would like to review any portion of the webinar, a recording will be available on our YouTube channel and on our website at eandm.com. Thank you again, and we hope to have you at one of our future webinars.
Thank you, everyone.